Hello and welcome to this demonstration of a food security policy workbench that was developed by Esri Canada as part of the Arctic Spatial Data Pilot Project. To develop this workbench, we used a web map application template with tabs for rapid access to important food policy issues. Let's quickly look at some of these issues in more detail. The first topic we will cover is how to find geospatial data. This tab shows all the Arctic geospatial data catalog portals that were deemed useful by the project. These 12 different portals allow users to search and find useful Arctic geospatial data and web services. Let's have a look at how easy it is to find and load web services into the policy workbench. Here's the Esri GeoPortal server. It has a large catalog of geospatial data sets from around the world. Let's search using the search term Arctic NWMS. Here are the results of the search. We can see that 37 records have been found, and let's have a look at the field research project information that was collected by the Arctic Research Mapping application. Here is the detailed metadata record for the field research projects, so let's copy the service URL that we will use in the next step. Here we have the web map with the field research data loaded. This map is in the Web Mercator projection, which is traditionally used in web maps, but is often not suitable for polar applications due to map distortion issues at the poles. In order to load the research project data, we went to the Add button, load a layer from the web, selected the type of service, paste in the URL, and hit Add Layer. Here we see that the WMS field research project data has been loaded, but also the ArcticSDP Pan-Arctic base map that we were requested to use by the project sponsors was also loaded as the base map. The changes in the map projection to the polar stereographic projection gives the viewer a better vision of the Arctic. Policymakers need reference material, so on the Reference Maps tab, we have 4 different data sets that were loaded using 4 different types of web services, including WMTS, KML, WMS Web Map Service, and WFS Web Feature Service. Here we see a closer view of the reference maps. The reference maps show the transportation networks in Canada and the US, which could be used by the food security policymakers to examine access routes to food stores. The Alaska ice conditions is from the US National Weather Service. Next, we have the Landsat satellite data service, which has data from all the globe and most of the Arctic. Here we see it projected onto the ArcticSDP base map. The Landsat service is time enabled, and here we've zoomed into the Inuit area of northern Canada. We are showing an image acquired between 1997 and 2002. Which is clearly a summer image. Next, we have an image acquired between 2002 and 2007, and the next one is between 2007 and 2012. The final image is the most recent one, which is clearly a winter image. Next, we are showing the Arctic elevation data, which is accessing a web map service. Let's zoom into northern Canada near Baffin and Ellesmere Islands. Here we can see the gray hillshade layer. Next, we'll look at the aspect map, which shows the directionality of the hills. And finally, we'll look at my favorite one, which is the slope map. If we can zoom in, we can clearly see the darker areas, which are extremely steep terrain, and most likely wildlife and people would not be able to move easily in these areas. The next food policy issue we'll look at is store-bought food. Here we are showing the locations of retail stores in Canada and the US. If we click on these, we can see that this is Northmart in Newfoundland and Labrador, and we have other ones up in here, the Walmarts and the Safeways. The next layer is the density function. This purple area is the density function of where against the food stores. It was created using the analysis function in the toolbar. The layer indicates that people living within these areas are more likely to purchase food than people outside these areas, who are more likely to procure their food from the land or use what's called country food. Some additional information, such as the Arctic boundary in blue here, or the language areas, the gray polygons, can also be used by decision makers to provide additional information for food security decision making. Next, we will look at country food policy issues, and here we have loaded some land cover information with the coarser resolution data coming from the Canadian federal government and the finer resolution land cover data from the government of the Northwest Territories. This data was created from imagery data and thus is somewhat pixelated, but it does give the policymaker another source of information. In addition, various environmental areas information is given showing where hunting and gathering may be allowed and where it is illegal. Food security is often a local issue, so it's important to be able to ingest local data. This example shows data that was provided using the GeoPackage standard. It is data from the city of Iqaluit and contains local city data such as the location of hydro poles, culverts, and trails. For example, we can see the location of hydro poles here. The next example of local data is the Community Wellbeing Index that is provided by Statistics Canada as a web map service. If we click on an area or a community, we can see the Community Wellbeing Index. For example, this is Kenora, which has a Community Wellbeing Index score of 82. If we click on this area over here, which is called Repulse Bay, we can see their Community Wellbeing Index score is only 49. So this has been a quick tour of the food security policy web application using data that is available via web services. Thank you for listening.